Okay, so for this problem, we want to calculate I1 and I2 in phasor form using current divider rule. Okay, so to before we do that, you see we have two branches. I1 is the current for the first branch, and I2 is the current for the second branch. So we want to for our convenience, we want to convert this into two branches with impedance boxes. Okay, so we can do like this. For first branch, we just use Z1 as an impedance box, and for the second branch, we also use impedance box. We use Z2. Okay, so again, this is the current, and this is I1, and this is I2. Okay. All right. So based on current divider rule, we know that I1 will be equal to Z2 times I over Z1 plus Z2. Okay, and I2 will be equal to Z1 times I over Z1 plus Z2. All right, so here we have I is a known value, but we don't know Z1, Z2. Okay, so that means before we calculate this based on the current divider rule, we have to find out what is Z1, what is Z2. Okay, so Z1, you see, Z1 actually is for the first branch, and for the first branch we have only one inductor. Okay, so that means Z1 is the impedance for this inductor. So it will be JXL, and XL here is equal to 4 ohms, so it's J 4 ohms. That's Z1, and Z2. See, Z2 actually is the total impedance for the second branch. So the second branch, you can see we have two components. We have a resistor, we have a capacitor, and the total impedance for this branch is the resistor minus JXC. Because the impedance for the capacitor is negative JXC. Okay, so it's equal to R is 12 ohms, so it's 12 ohms minus J. XC is 6 ohms. 6 ohms. Okay, and if we want to convert into polar form, it becomes square root of 12 squared plus negative 6 squared with angle negative 6 over 12. Okay, and if you do the calculation, it becomes 13.42 ohms with an angle of negative 26.5 degrees. Okay, so and then we want to find out the total, the summation of these two individual impedances. Okay, so Z1 plus Z2. Z1 is equal to J 4 ohms, and Z2 is here, plus 12 ohms minus J 6 ohms. Okay, so these two J's add together, it becomes 12 ohms minus J 2 ohms. Okay, so this is in rectangular form, and we want to convert this into polar form. So for polar form, we have square root of 12 squared plus negative 2 squared. For the angle is 10 negative 2 over 12. Okay, so if you do the calculation, it's equal to 12.16 ohms with an angle of negative 9.46 degrees. Okay. All right. So once we have all these individual impedances, and for this Z1, if we want to convert this into polar form, it's equal to 4 ohms with 90 degrees. Okay. All right. So for I1, let's rewrite this a little bit down here. Okay. So I1 is Z2 times I over Z1 plus Z2. All right. So Z2 is here. Z2 is here. It's 13.42 ohm with negative 26.5 degrees times I is here is 6 amps with 30 degrees, and the summation of these two is here. It's 12.16 ohms with negative 9.46 degrees. Okay, and as we did before, you multiply all these amplitudes, multiply this two over this, you get the amplitude. And for the angle, negative 26.5 plus 30 minus negative 9.46. So do all the calculation, you will have 6.62 amps with an angle of 12.96 degrees. Okay. All right, so that's for I1. And then for I2, again, with the current divider rule, you have Z1I over Z1 plus Z2, okay? All right, so it's equal to Z1 is over there, is 4 ohms with 90 degrees, times I is here, 6 amps with 30 degrees, over this Z1 plus Z2 is 12.16 ohms with an angle of negative 9.46 degrees. Okay, so it's again 4 times 6 over 12.16 is equal to 1.97 amps with an angle. Angle will be 90 plus 30 plus 9.46. Actually, it's a minus negative, but minus negative becomes plus. So it will be 129.46 degrees. So this is the phasor form for current 1, I1, and this is the phasor form for I2.